Hey guys, all right, here's a quick explanation that I wanted to add to the understanding of the neutral's role in a multi-wire branch circuit when it comes to three-phase panels, okay? Different from a single-phase panel, right? In a single-phase panel, like this one or this one, if you use the hot for one circuit, right, or a string of outlets, as I said, in a living room or bathroom, living room combination. We always combine a couple of rooms together. And then you have your other circuit here with same thing, a string of outlets to other bedrooms and extra bathrooms or hallways and etc. If we share the neutral, which is again the definition of a multi-wire branch circuit, to more than one ungrounded conductor with a shared neutral. And as you plug things into this circuit, here's the first question that I want to make sure you know how to answer. Okay? If I plug in, let's say, something and we're drawing 2 amps here, and we plug in something to this outlet, and this one is drawing 5 amps, and we plug something into this outlet and this one is drawing 12 amps. So first of all, we have 12 plus 5, 17 amps, plus 2, 19 amps. So this should be a 20 amp circuit. Well, we'll say it's a 20 amp circuit. And we'll say the other breaker as well is a 20 amp circuit as well. All right, two 20 amp circuits. And I plug into the other circuit as well. In this one, we have 4 amps, plug in something to that one, generating 11 amps, and plug in something to this one, and let's say only 3 amps over here. And again, we can count all these up. 11 plus 4, 3, 17, that's 18. 20 amp circuit is covering both of these. Now, the question to ask yourself is, how many amps are on this neutral? So all you have to do is, it doesn't get too complicated. All you have to do is add up both. So on one circuit, we'll call this circuit 1, circuit 2. On circuit 1, all right, we have, as we said, 7, 5 plus 2, 7 plus 12, 19. By the way, close to. We're writing really tight to that 20. It's okay. And it's just an example. And the second circuit, we have, as we said, 17. No, sorry, 18. Sorry about that. Yeah, 7 plus 11, 18. So the neutral is only dealing with 1 amp. That's all the neutral is carrying in this situation right now. Now remember, as I said, why do we want a large size neutral if it's only carrying 1 amp? Why don't I just make it a 22 gauge wire? Well, if somebody disconnects this, and let's say disconnects this one, this starts to now we only have 2 amps on one circuit, right? We still have the 18 on the other one. So now the neutral is dealing with 16 amps. 18 minus 2. We put the numbers reverse for proper subtracting, but. So this is why we have to make sure our neutral is sized correctly. All right, going back to the situation we had. So this is 1 amp. Single phase circuit, meaning A phase and B phase is what we call a single phase panel. Let me take this over to a 3-phase panel though. And by the way, for that question, hopefully, well, you're ahead now, so hopefully everybody paused and did the math for themselves. But in a 3-phase panel, you have a third phase. So this adds a extra thing you got to think about in this situation. So let's say here again, we have a circuit, string of outlets, however many, doesn't matter for this example. Other circuit, same thing, couple outlets, couple outlets. Shared neutral, right? We run our neutral. Plug in a bunch of stuff to this outlet, this outlet, this outlet. Let's say accumulated amperage on that circuit, 16 amps. Plug into this outlet, this outlet, this outlet. Accumulated amount of amperage of whatever, say 13 amps. Here's the problem. Single phase circuit, this would be 3 amps on the neutral. But in this three-phase system, when you have a third phase, if you do not use the third phase in this multi-wire branch circuit, then now this neutral is carrying the accumulated amount. So 29 amps are on this neutral because you are only using 2 phases out of the three-phase system. For you to be able to balance, use that balance feature of those magnetic fields that I was talking about from one phase and the other phase, right? We have our A phase, our B phase circuit. The magnetic field from A phase and B phase only cancels each other out when the other phase is with it. In other words, you would have to run a third circuit. Now they're using blue. I'm not going to use blue here. All right, I'm just going to use black. But understand that this is the C phase circuit now. Let me draw a better C there. And again, a bunch of string of outlets. So in a commercial building, this is how you have to do it. In any system, I would say that you have the three phase. Now, 16 amps on one circuit, 13 amps on the other circuit. And let's say on this one, again, plug in, plug in, plug in, only 10. This is where the math gets fun. Now it's the unbalance of all 3 of them. All right, the unbalance of all 3. You can do this math however you want. You can do this math however you want. You can start with, let's say, 16 minus 13, 3 amps. And now 10 minus 3 amps. So our total unbalance is, and what the neutral is carrying, is 7 amps. You can pause this and work out that math for yourself and understand how to do it. So in a three-phase system, you have to use all 3 phases in the multi-wire branch circuit. If not, you get this accumulated amperage on the neutral. We do not want that. In this situation now, this neutral is only carrying, like we said, 7 amps. In a single-phase system, now it works itself out. So in a single-phase system, we would not add a third one to this one because we'd be bringing in one of the same phases that we already had. Now we can, well, we can, but we'll get into that conversation later on. Okay, so let's do this just to make this a question you guys can answer on your own while you're looking at this. So let's say, and here's my question to you. On A phase, all right, plug in, plug in, plug in, plug in. We have a total of 12 amps on this circuit. B phase, we have a total of 7 amps on this circuit. C phase, we have a total of 17 amps on this circuit. Pause the video here and tell me what amperage is on that neutral. All right, if you unpaused it, and I even paused myself there for a second, here's the answer to your question. Again, you can take any 2 numbers here. I'm going to take the 17 amps and the 7. It's just easy math right now for me. That becomes 10. And now we bring the 12, subtract it by 10, 2 amps is what our neutral should have. All right, if you got that correct, good to go. And I hope you found this video useful. And if you have any questions on this video, you can ask it during lecture. That would be fine. Maybe somebody else has the same question and we can explore it. But you can also send me an email directly and we'll one-on-one the situation. All right, good to go.